So this is the first video where we're going to be looking at pulleys. So when we're looking at pulleys and we have things hanging off them, we're going to take each individual particle and we're going to draw a diagram for it, and we're going to write equations for it. So if we're going to take them out like this, and we're going to decide firstly which way are they going, and that's the direction our acceleration is going to go and our equations are going to start in. You can see if the 4 is heavier than the 3, we're going to go down this way. So this is my acceleration A. What's happening with my 4? I have 4g coming down like previously. I also have 3g coming down. I have this T, this taut inelastic string or tension. I'm going to have tension in this string. It's the same string, so it's the same T. So what would be the resolved forces here? Well, for this one, it's going down, so we're going to start with 4g. So 4g minus T are the resolved forces. That's equal to the mass 4 times the acceleration. And in this one, the T, it's going up in this direction. So T, and it's the same acceleration. T, we will be looking at where we have multiple pulleys, and we'll be having acceleration A and B and A plus B and A minus B. But in this case, just one acceleration for now, and the equation here is T minus 3g is the resolved force. That's equal to M times A, and you can see now junior cert simultaneous equations. You can nearly see what's happening here. You can write this one underneath here. The T's are going to cancel, so I'm going to put the minus 3g first. Minus 3g plus T is equal to 3a. So in this case 7a is equal to g, and we're looking for acceleration, so acceleration is equal to g over 7, which is 9.8 over 7, which is 1.4 meters per second squared. So now we want to get the tension. Well, we have A, we have G. So now tension, I can just fill back in here. Tension is equal to 3A plus 3G. So the tension in the string is 3 by 1.4 plus 3 by 9.8. So the tension in the string is 3 by 11.2, 33.6 newtons is the tension in the string. The speed with which the 4 kilogram mass will hit the table. So here's my 4 kg. It's going to hit the table. We have a 2 meter distance. So S is equal to 2. It has to travel 2 meters. And we have acceleration as 1.4. We also know that this system starts from rest. So the initial speed is 0, and we're looking for the speed with which it will hit the table. So we can definitely use v squared is equal to u squared plus 2as. So we're looking for v. It started from rest. I've got a 0. So v squared is equal to twice my acceleration by the distance it has to travel. So v squared, 4 by 1.4 is 5.6, and the square root of 5.6 is 2.366, 2.37 meters per second for the speed that the 4k will hit the table. And how much further will the 3k rise? So as the 4kg hits the table, the 3kg will continue to rise for a bit before stopping and coming back down. So what have we got going on then for 3? I'll go back up to the diagram. So as 4 hits here, 3 is here. What speed is it going? Well, it's going the same speed as 4 was when it hit the ground. So its speed is that 2.37. What's going to happen to it? It's going to rise, 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 rise. It's going to momentarily stop. Velocity is going to become 0 before it starts to come back down. Now, as it's coming back down, its acceleration is 9.8, but as it's going up, the acceleration that's slowing it down, it's minus 9.8. And we can get the distance using v squared equals u squared plus 2as. So my 0, because it stops at the top of its momentum, is equal to, well, that was the square root of the 2.37 was rounded off. It was the square root of 5.6, wasn't it? Square root of 5.6, so I'll round that back up then, plus twice by minus 9.8 by the distance that it's going to travel, and that's the square root of 5.6 to be squared, so that's going to be 5.6 divided by twice 9.8 is going to give me the distance that it will travel. Does that work out evenly? 2.8 over 9.8, 28 over 98, which is 2 over 7 meters. And that's how far it will travel before it starts to come back down. That's the end of this example, the first example on pulleys. You're going to love these questions the more of them that you practice. So move on to number 16.